Hello there. In this video we're going to convert some equations from standard form into vertex form via completing the square. So in this one I got x squared minus 6x plus 13. I'm going to look at what this middle term is here, minus 6x, and I'm going to take half of that, which would be a minus 3, and then I got to square it. Which would be a 9. So it would be really nice if this were x squared minus 6x plus 9, because I know that would factor nicely. But it's not. I got this plus 13 over there. So here I'm adding a 9, and over here I'm going to have to subtract a 9 to counterbalance that. This part can still get factored, x squared minus 6x plus 9. That part's nice. That's just simply x minus 3 quantity squared, and then this last part, plus 13 minus 9, that's going to become a plus 4. And that's my vertex form. And vertex form is nice because you can simply look at these things and start identifying like the min-max points. This one has a maximum at 3, 4, and we can do that by looking here, flip this one positive 3, plop that one 4. And if I want to, I can also identify other things like y-intercept. This one is actually quite nice from standard form. I can just look up here. But you can also do it here, plug in a 0. Negative 3 squared is 9. 9 plus 4 is 13. And vertex form will also let us get the x-intercepts pretty nicely. X-intercepts is when y is equal to 0. So you're going to set this up 0 equals x minus 3 quantity squared plus 4, and then you're going to have x minus 3 quantity squared equals negative 4, taking the square root of both of these sides, and you got the square root of a negative, so that's going to lead to no x-intercepts. So, okay, we got that one. Now over here, we have a coefficient in front of the x squared, so this becomes a little bit more sophisticated, and we're actually going to have to factor out that 2 from these lead to. Not worrying about the 9 at the end there, that's something else, but factor it out of these, because we want to get it into this form of x squared plus or minus something. So I'm building the structure over here, I got the 2 factored out. It's going to leave me with this, and I'm going to add something, and then over here I'm going to take it away. And what is it that I'm going to add? Well, let's change our colors here. Looking at this number, negative 5, I got to take half of that. That's 5 over 2. And then I have to square it. So I'm adding in here 5 over 2 quantity squared, and then over on the other side I want to subtract something, but I can't simply subtract 5 over 2 squared, because that's not what I added in its entirety. This 2 actually gets distributed through. So I'm actually subtracting 2 of these things. Okay, let's expand this out a bit. No reason to really expand the left to 25 over 4. That's not necessary. It's going to reduce to this. But over here I got plus 9 minus. This is going to be 25 over 2 when all is said and done, right? Because it's over 4 and those 2's cancel. Okay, so let's reduce this. I'm realizing there's a mistake in here. This is not an x squared in there. That's just x to the first. Whoops. Okay, so here we get x minus 5 over 2 quantity squared. Let's get the same denominator. This is 18 over 2 minus 25 over 2. So our equation, all in all, is going to be minus 7 over 2. All right. So, some questions about the vertex. The vertex for this one is going to be a maximum. We're going to flip this. It's at 2.5, 5 over 2, comma, plop this one, negative 7 over 2. Or 2.5, comma, negative 3.5. And that is a maximum. The y-intercept at 0, 9. Now, easiest to get that from here. However, you can also plug in a 0 into this. You get negative 5 over 2. You're going to square that. You're going to get 25 over 4. which is going to be multiplied by 2, and you'll get 50 over 4, which is 25 over 2. Subtract 7 over 2, and you get 8 over 2, 18 over 2, and that's 9 there. And this one, I think, will actually have some x-intercepts. So let's build a little bit of space. So remember, we're setting it up where the y is now 0, because we want the x-intercept. And you can move the 7 over 2 over. You get this. And now we can divide by a 2. So I'm going to get x minus 5 over 2 quantity squared. Dividing by 2, I get 7 over 4. And at this point, we can take the square root of both sides. So on the left, I'm going to get x minus 5 over 2. On the right, I'm going to get the square root of 7/4, so it's going to be plus or minus. Top is still square root of 7. The bottom is going to become a 2. And then I can add that 5 over 2 to the other side. So I get x is 5 plus or minus root 7. They have the same denominator, 2, all over 2. Now we want this as coordinate pairs. So our x-intercepts is 5 plus root 7 all over 2 comma 0, and 5 minus the square root of 7. Whoops, that's getting ugly there. 5 minus root 7 all over 2 comma 0. That one got a little bit longer than I was anticipating in it, but it's a pretty slick way of completing the square to solve for your x-intercepts. You don't need to use the quadratic formula on it. If you're going to vertex form to figure out where your min-max point is, you can just continue on with that and figure out your x-intercepts too. Okay, thanks for watching. Character and Scholarship for Life.